In this segment, we describe how needles actually do their work. How are the needles arranged, and what causes them to move? Knitting machines are designed so that each needle can be placed in a groove, cut into the outside of a metal cylinder. Before we show you how these cylinders work, let's define the parts. The cuts or grooves may also be referred to as slots or tricks. The top edge of each groove is called the verge. These cylinders are very precisely manufactured, so the diameter measured at any place is equal. Machines are classified by the number of cuts per linear inch. This is referred to as the cut or gauge of the machine. For example, an 8-gauge machine has 8 cuts per inch. The total number of cuts around the circumference of the cylinder would indicate the number of needles in the cylinder. The more needles, the wider the fabric. Now let's take a closer look at the needle itself and label its parts. At the top of each needle is a hook. Below this is a latch, attached with a rivet. Notice that the bottom edge, or cup of the latch, is curved to fit over and completely close the hook. At the bottom of the needle is a butt, which plays a part in controlling how needles activate, up or down. A needle with a latch is very efficient. When the latch needles are used to create weft knits, the knitting cycle can be completed without any auxiliary attachments. Here's how the latch needle works. At rest, or running position, a knit loop rests above or on the latch. As the needle moves up, the old loop, already formed, drops below and clears the latch. As the needle moves down, it receives the new yarn to begin forming a new stitch. The latch is knocked over by the old loop, and this old loop is cast off. The needle moves further down to fully form and complete the new stitch. The amount of yarn used to form a new stitch determines the stitch length. This is important because stitch length affects the weight, width, and aesthetics of the fabric. On modern-day knitting machines, needles make millions of loops or stitches a day. Needles may need to be replaced due to wear, but they usually last up to 6 months, depending on construction, yarn type, fiber type, and speed. Next, let's take a look at what causes the needles to move up and down. In this illustration with a side view, you see how the butt of a needle guides the needle through a path formed by cams. Each cam is designed to allow the needle to run straight or to move up and down. Here's how the needle travels through various stages. At the rest or running position, the needle runs straight over the rest cam. When it hits the clearing cam, it rides up at a steep angle, which forces the needle to rise and clear the old loop. Then the needle drops when it contacts the stitch cam. As it continues on its path, it catches the new yarn. It continues further down, pulling the new yarn far enough for a new loop or stitch to form as the old loop is cast off. The up-throw cam returns the needle to its resting position so it can begin the cycle again. Take a look at this same action while the machine works. Watch how needles run through the camways, which cause the needles to rise and fall. And remember that this machine has a cylinder that contains vertical grooves and slots to hold the needles that move. As needle activation occurs, how does the machine control the movement of fabric as it knits? There's one more part, placed between each pair of needles, that you need to see to better understand this. It's called a sinker, and here's what it looks like. It's a thin steel element with a distinctive shape. This illustration highlights the parts. A sinker has a butt with a place to insert a cam. It has a hold, a throat, and a nose. As the needle goes up, the sinker moves in to catch the fabric in its throat. Since the fabric can't go up with the rising needle, the old loop now clears the latch. When the hook catches a feeder yarn as the needle moves down, the sinker moves back out of the way, and knockover, cast off, and stitch forming takes place. As the new stitch is formed, the fabric rests on the top of the nose. Here's one last view of needle activation to show you how knit fabric is formed